Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through graphing any parabola. I say graphing any parabola because other methods you may have learned, like table of values, can't be used on any parabola. So the problem with something like a table of values, it's very elementary. It gives a good introduction, but it doesn't allow you to see all of the features of the parabola. When using a table of values, you might not be able to get from that what the turning point is, what the x-intercepts are, even if there are any x-intercepts. And so we need another method of graphing parabolas. So the method I'm going to go through today, basically you find 4 features of the parabola, plot them and join them, easy as that. So just before we get into it, I just want to remind you that a parabola is the graph of a quadratic equation. So all of the quadratic equations you see can be written in this form. Y equals ax squared plus bx plus c. X is a variable. It changes from question to question. A, b, and c are just numbers. They're constants. So from this equation, we can find out 4 features for any parabola. So the first feature we look for is the orientation. So that's saying which way up the parabola is. So that's totally determined by A, the number in front of x squared. So if A is positive, then the parabola is a smiley face. And if A is negative, then the parabola is like upside down, a frowny face, okay? I'll just point out very quickly at this point that only the advanced students are doing non-monic quadratic equations, and that means that only advanced students are going to look at quadratic equations where the number in front of x squared is not 1. So this video is for advanced and mainstream students. Okay, the second thing that we look for in a parabola is the y-intercept. Every parabola has a y-intercept. If it's written in this form, ax squared plus bx plus c, the y-intercept is just the point 0, c. That's where it hits the y-axis. Otherwise, if it's not in that form, then you just let x equal 0. So what I said before was that any parabola, any quadratic equation can be written in this form, but that doesn't mean it will always be written in this form. It may be factorized form. It may be something like y equals x plus 3 times by x plus 4. You can expand it in that case to get something that looks like that. Okay, the third thing you need to find is probably the hardest of them all. It's the x-intercept. So what you do here is you let y equal 0. Now this isn't new to you. We did this in linear relations. If you want to find the x-intercept, you let y equal 0. If you want to find the y-intercept, you let x equal 0. So why this is hard is you'll have to solve a quadratic equation. You'll have to solve the equation ax squared plus bx plus c equals 0. So as we've been doing for the last couple of lessons, that usually involves factorizing and using the null factor law. So the last thing you need to find, and we can sort of do 2 in 1, it's the turning point / axis of symmetry. Every parabola has a turning point and has an axis of symmetry. I should, have pointed out that not all parabolas have x-intercepts. Sometimes they have 0, sometimes they have 1, sometimes they have 2 x-intercepts. But in Year 9, we're only considering parabolas that do have x-intercepts. So the turning point or axis of symmetry can be found using this equation, x equals minus b over 2a. So b is just the number in front of x, a is the number in front of x squared. You use that formula. So x equals a number. Remember from when we did linear relations that that's just a perfectly vertical line like that. So the axis of symmetry is a line whose equation is x equals some number. That number is minus b over 2a. Minus b over 2a is also the x-coordinate of the turning point. So you will need to substitute that in and find the y-coordinate of the turning point. Okay, now hopefully this will become a lot clearer when we look at an example. So let's start with the example. Y equals x squared plus 7x plus 12. So what I'm going to do with this quadratic equation, I'm going to go through one by one and find all of these 4 features. So firstly, the number in front of x squared, if nothing's written, is 1. That's obviously positive. A is positive because it's 1. So that means the parabola is going to be a smiley face. Secondly, the y-intercept. If I let x equal 0, then y will be 12. This is the value of c, so the y-intercept is going to be 0, 12. So, thirdly, I'll find the x-intercept. So I have to let y equal 0. So I have 0 equals x squared plus 7x plus 12. Now, hopefully you remember how to solve these. What we do is we factorize. We find two numbers that multiply to this and add to that, which is 4 and 3. So it'll factorize like this. And then we use the null factor law. So, either the first thing equals 0, which would mean x equals minus 4, or the second thing equals 0, which means x is minus 3. So this parabola has two x-intercepts, -4 and -3. So the last thing we are going to do is find the turning point and axis of symmetry. So here, b is 7, a is 1. So minus b over 2a equals minus b over 2a, which is minus 3.5. So that means that the axis of symmetry is x equals minus 3.5. It also means that that's the x-coordinate of the turning point. So let's find the y-coordinate. So if x is minus 3.5 and we put it into this equation here, the y-coordinate is just minus 3.5 squared. So x squared, we need the brackets there, plus 7 times x plus 12, which is minus 0.25. So therefore, the turning point is at minus 3.5 minus 0.25. Okay? So what I'm going to do is go to a new slide, and I'm going to plot all of these features, and then we will have the graph. So please pause and copy this down if you need. So what I've done here for you is I've listed all the features that we found on the previous slide and also drawn up a Cartesian plane. So now we're just going to plot all these features, and it doesn't matter particularly the order in which the things are graphed. So let's start off with the y-intercept. So the y-intercept is 12, I'm just going to plot that. The two x-intercepts minus 4, minus 3, I just plot that. So the turning point x is minus 3.5 is here, so y is minus 0.25 is about there. So we know that it's going to be the right way up in a smiley face, so we use our knowledge of the shape of a parabola. So we join up all those points, and because I know how a parabola looks and symmetrical, it's going to go like that as well. So this is just a rough hand drawing. So you can see the axis of symmetry is this line that goes through the parabola like that. Okay, so mainstream people can stop watching now. I'm going to do two more examples more for the advanced students. Okay, so like I did last time, what we'll do is we'll find our features first, then we'll graph both at the same time. So let's start off with y equals, let's say, minus x squared minus 4x minus 4. Okay, we're going to graph that parabola, and we'll also graph y equals, let's say, 2x squared minus 5x minus 12. We'll do both of those. Okay, so first thing to do is we'll look at the orientation of both. So in this one, the number in front of x squared isn't 1, it's minus 1. So because a is less than 0, negative, that means that this will be a frowny face. But here, the number in front of x squared is 2, so that means it'll be, this one will be a smiley face. Second thing is the y-intercept. So you can see that both of these are in the form y equals ax squared plus bx plus c. So c tells you the y-intercept. So 0 minus 4 is the y-intercept of the first one, and for the second one it would be 0 minus 12. Okay, third thing, let's look at the x-intercept. So that involves solving a quadratic. So if we have 0 equals minus x squared minus 4x minus 4, so hopefully you remember from previous lessons, we can only use the trick of two numbers that multiply to this and add to this if it's monic, if the number in front of x squared is 1. Here it's not, but we can take out a factor of minus 1. They have a highest common factor of minus 1. So I can write my thing like this. x squared plus 4x plus 4. Okay, so I just changed the sign of everything and put a minus sign out the front. This expression here and this expression here are exactly the same. So I can solve this bottom one, which is a little easier to solve. So if 0 equals minus something, if minus something equals 0, then that something must be 0. So in a sense, I'm dividing each side by minus 1 to get this. Okay, so it is okay when you've got an equation and one side equals 0 to just change the sign of everything when you're solving. It will be a different parabola than the one I have now, but the solutions will be the same. What I mean is this here, minus x squared minus 4x minus 4, is a different parabola than y equals x squared plus 4x plus 4. But when I'm solving, I can solve this bottom one because they will both have the same x-intercepts. So now that I have the number in front of x squared equal to 1, I can use the trick of two numbers that multiply to this and add to this. It turns out that in this case they're both the same. So this is 0 equals x plus 2 squared, so there's only one solution, and that is that x is minus 2. So there is only one x-intercept for this. So the last thing we do is turning point axis of symmetry. So x equals minus b over 2a, which is minus 2. So the axis of symmetry is the vertical line x equals minus 2, which also happens to be the x-intercept, and that means that the turning point occurs here too. So if you substitute in x is minus 2 into this equation, you'll get y equals 0. So minus 2, 0 is the turning point. So here, the turning point, axis of symmetry, and x-intercepts are the same thing. And that's no coincidence. If a parabola has one and only one x-intercept, that x-intercept will also be the turning point. Okay, let's go through and do the second equation. So I want to find the x-intercepts. I have 0 equals 2x squared minus 5x minus 12. Okay, so remember, we can't use the trick of two numbers that multiply to this and add to this because the number in front of x squared is 2. This is trickier because there's no common factor. 2, 5, and 12 don't have a common factor. So I can't use that method. Remember, I have to go through the bridge or the AC method, whatever you like to call it. So what I do is I multiply A and C together. That's why it's the AC method. So 2 times negative 12 is negative 24. So then what I have to do is I have to find two factors of negative 24 that add to negative 5. So you can just go through factors of negative 24. Hopefully you see 8 and 3 works because they differ by 5. You just have to figure out which is positive and which is negative. So because I want negative 5, I'm going to use negative 8 and positive 3. Okay, so what I do is I split up this middle term into negative 8 and positive 3. So I go 0 equals 2x squared minus 8x plus 3x minus 12. I haven't actually changed the quadratic equation yet. So this equation is exactly the same as this one here. So then what I do is I factorize by grouping. So I factorize the first two using common factors. So the common factor is 2x. So 2x squared divided 2x is x. Negative 8x divided by 2x is negative 4. Plus, and the second two terms have a common factor of 3. 3x divided by 3 is x. Negative 12 divided by x is negative 4. The brackets should be the same. This and this should be the same, otherwise you've done something wrong. So here they are. So take out common factor of x minus 4. That is my parabola factorized. Now I just use the null factor law. So either x minus 4 equals 0 or 2x plus 3 equals 0. So in that case, I subtract 3 and divide by 2, and I get x equals minus 3 over 2, or 1.5. Okay, so finally, we look at the turning point and axis of symmetry. So x equals minus b over 2a. So 2 this time a is 2, and you get positive 1.25. So that x equals 1.25 is the equation of the axis of symmetry. Now we find the y value so we can get the turning point. And if you substitute x is 1.25 into the original equation, you should get y equals minus 15.125. So that's the turning point, minus 1.25, positive 1.25 minus 15.125. So now, pause and copy this down if you need, and we will graph this on the next slide. Okay, so I've got the Cartesian plane drawn up, and first we'll graph y equals minus x squared minus 4x minus 4. So we discovered on the previous slide that the y-intercept was minus 4 and that there was one x-intercept at minus 2, and that was also the turning point. We also know that the parabola is a frowny face, so we can see the way it's going to go. It's going to go like this, and it's going to be symmetrical on the other side. I know that this is just a rough drawing and yours will look more beautiful. Okay, but that's enough there because we can see from that what the turning point is, what the y-intercept is. That's enough to characterize a parabola as well as knowing the x-intercepts and the axis of symmetry. So that one's done. Y equals minus x squared minus 4x minus 4. Now let's do the other one. So do that one in a different color. So that one was y equals 2x squared minus 5x minus 12. So we know that that's going to be a smiley face. So we know that the y-intercept is minus 12. We found that there were two x-intercepts. So there was an x-intercept at positive 4 and there was an x-intercept at minus 1.5. So we plot them. So the turning point was minus 1.25, with the x-coordinate's about there, and then the y-coordinate, that was minus 15.125. So we just need to estimate that. So that's going to be like around about there. Okay, so now I just join that up knowing that it's a smiley face. And so this is what the parabola will look like. Again, I know that it's not the easiest for me to draw on the iPad here, but as long as it's clear what the y-intercept is, what the turning point is, and what the x-intercepts are, that's enough to characterize the parabola and show that you know what you're doing. I'll just write the coordinates of the turning point because it isn't actually that easy to just see it. So that was minus 1.25 minus 15.125. That was the coordinates of the turning point. Alright, thank you so much for tuning in. Sorry for the long video. This has been the luckiest maths teacher in the world. Have a great day.